Okay, so integration. Integration is the opposite of finding a derivative. Now, we've got two basic rules. Basically, what's going to happen is that we are going to either add 1 to the exponent, and then we're going to multiply by the reciprocal, or we're going to divide by the new exponent. I don't recommend, technically this is the rule. If I'm finding the integrating any kind of term that's got a power, then this is technically what I'm doing, but it's really hard to remember as far as what's going on. So if I'm finding an integration, if I'm doing integration, I'm going to add 1 to the power, and then I'm going to divide the term by the new power, or I'm going to multiply the term by the reciprocal. And then if I get a constant, if I have to integrate a constant, then I'm just going to put an x on the end. And then whenever you integrate and you don't have any boundaries, you put a plus c at the end. Does that sound familiar? Do you remember doing that before? Giovanni, you with me?
Yeah, I'm with you.
All right, so the thing is that if I find the derivative of this, it's going to be 6x plus 2. Do you agree with that?
Yeah.
And if I find the derivative of this, it's also going to be 6x plus 2. The problem is that this constant at the end of the original equations, we never do the derivative of it. Because keep in mind what happens is that derivatives are about slopes and curves. And all this number at the end does is move it up. So for example, clearly this is a quadratic. And if it looked like this, and say for example, I made it plus 7, it would be the exact same quadratic, only it would be up 3. So what happens is all the curves and all the slopes, they don't change. So that's why when we do the integration and we don't have any limits, we always have to put a plus c at the end, because there's no way for us to know if there was another constant or not. Does that make sense?
Yeah.
All right, so what I want you to do is we're going to try doing some integration. And remember, this symbol is basically means to integrate. This means to do it in terms of x. And so these are pretty simple ones. We're going to start with some simple ones. I'm going to start with 5. And then what am I going to do?
You're gonna add 1 to the power.
So now it's a 6. And see, now I'm either going to divide by 6 or multiply by 1/6. In this case, I think it's easier to just divide by 6. So what do I get?
You get 2.
All right. Now, that's all there is to it. And then I've got to put a plus c. Do the other two for me.
Alright, so for B, I got 5x to the power of 4. And for C, I got negative 3x to the power of negative 1.
So you made this a 4, divided by 4, and you got 5, and then you put a plus c on it?
Mm-hmm.
And then what do you, for this other one?
For C, I got negative 3x to the negative 1 power, or negative 3 over x negative 3 over x plus c.
Right. Okay. So negative 3 over x plus c. All right. So take a look at this one then. A derivative versus an integral. A derivative is a function that we use to find slopes of tangent lines. It's identified by a specific x value. One purpose of integration is to take a derivative and change it back to its original function, and we call that an antiderivative. Let's try doing some of these. These are a little more tricky. What do we have to do first?
You have to put the bottom number on. Well, you have to put the bottom number to the top in order to find the derivative because you need exponents.
So, what's the power going to be?
No, -2.
And so then when I go to do the integration, now what am I going to do?
You'll add 1 and then divide 3 by 3 divided by -1.
So tell me about this one then.
You'll do the same thing. You bring up the 2. Well, yeah, you bring all of them to the 2x tree, the 2x to the power 3.
So what's going to happen is I'm only going to bring up the x. Now
Oh
notice.
yeah, I remember. Okay,
now notice it's only the x that's to the power of 3. So what happens is it's going to stay. The 2 is going to stay at the bottom, and the x is going to move up. And what's it going to become?
-3.
And see, another thing is that I could rewrite that as what?
Oh, yeah.
Because you see how if I had 1/2 and I multiplied it times x to -3 over 1, I would just go straight across and it would become this. Well, 1/2, if I pull it apart, it makes it a little bit easier, I think, when I'm doing the integration. So now if I'm going to integrate this, what am I going to do?
You add 1 to the power and then you divide it. Or in this case, multiply the reciprocal to make it more easier.
So in this case, it seems like it makes more sense to multiply by the reciprocal. So what am I going to end up with?
-1/4.
And then plus c, right?
Yeah.
All right, so what's different about this one?
This one has a square root.
So what am I going to do with that one?
So it's going to have the power of 1/2, so you'll just bring it up again and you get the power of -1/2.
So then what am I going to do?
You'll add -1 by 1, and then from there on, you multiply by the reciprocal.
So if I add a 1 to this, what am I going to get?
I'm pretty sure I get 1/2, but I'm not sure.
Yeah, I'm going to add, and I'm going to get 1/2.
Right, yeah.
And then what am I going to do?
You'll multiply the reciprocal and you get 2.
So.
Oh, wait, no. Yeah, okay, same thing, yeah.
I'm either going to multiply by 1/2, or I'm going to divide by 1/2 or multiply by the reciprocal.
Yeah.
So which one do you want to do?
I'll say just do. No, because if you do it by reciprocal, what would that be? Like, the reciprocal.
So if I divide by 1/2 or multiply by the reciprocal, what's the reciprocal of -1/2? What's the reciprocal of 1/2? What's it mean to be a reciprocal?
I thought it was just like the bottom number, but I don't know if that's true.
What we're going to do is we're going to flip it upside down.
Oh, yeah. Yeah.
Right?
Yeah.
So if I divide by this, or I could multiply by -2. What happens when I multiply by -2?
Yeah, -2.
Well, -2 times 4.
Wait, you said 4 divided by 2 or 4 divided by -2?
So again, either because now I've got this 1/2, right?
Yeah.
So I'm either going to divide by 1/2 or multiply. I'm sorry, I'm saying negative. I'm either going to divide by 1/2 or I'm going to multiply by 2. What do you want me to do? 4 times 2?
Yeah, I just do 4 times 2. That's easier.
And that's going to give me 8x to the 1/2. And then what am I going to do with that?
You put a plus c.
We're going to make it back to probably a square root, right?
Oh yeah, that too. Yeah.
And then put the c in there, right?
Mhm.
All right. So take a look at this one then. Take a second and find the derivatives of those.
All right. So for a, I got x to the power 5 minus 2/3 to minus 2/3 x to the power 3 plus c and
2/3
yeah,
x to the power of 3.
yeah, and plus c.
All right, so let's talk about this. How did we get there?
So what I did, I added 1 to the power and divided by the power, or divided by the number that's next to the x.
So that gives me a 1, right?
Mm-hmm.
Okay. Now, talk about this one. What am I going to do with this? Start by writing the letter.
Uh-huh.
And what am I going to do with the power?
You got by 1
So now what's it going to be?
to the power 4. I miswrote it, my bad.
All right, now it's a power of 4.
Mm-hmm.
Now again, what am I going to do to this number? I'm either going to divide it by 4 or multiply by 1 over 4. Sounds like it's better to divide by 4. What's negative 2 divided by 4?
Negative 1/2.
So this is going to be negative 1/2, right?
Mm-hmm.
Now, tell me about this. What if you've got a constant?
That'll become plus 2x.
Exactly. And see, the reason that's so confusing is because what do I do when I'm doing derivatives with a constant?
Get rid of the x.
Exactly. Well, I get nothing, right?
Mm-hmm.
When I'm doing derivatives, I see a constant and I ignore it. And so the tough part about doing derivatives is, and integration, is the fact that they're so similar, but they're opposites and backwards. So try doing this one.
So for that one, let me make sure that I did a little mistake. So caught off guard like what you did. So like for minus 2x, I put just minus 2.
All right. So and again, so keep in mind what you did was you found the derivative of that, right?
Uh-huh.
All right. So let's start from the very beginning. What are we going to do here? X to the 6th divide by 6. What's that going to be?
That'll give you 1/2.
Okay. Now we'll start with this. Write the x, raise the power, and then either divide by 3 or multiply by 1/3. And see, in this case, I'd rather just multiply by 1/3.
Yeah.
And then here, it's a 1 right now, right?
Right.
That's why people always mess this up, because it's not written. But
Yeah.
it's a 1, so now I make it a 2. And what's negative 2 divided by 2?
Negative 1.
And then I put a plus c, which we got to do for both of these.
Yep.
Right?
Yeah.
Now, if I was trying to find an equation, if I was starting with a derivative and I was trying to find an equation, it would look like this. Now, what would be the thing that I would have to do in order to find what c? How would I find c? Do you remember?
You need boundaries, right?
Well, Typically, what's
Oh,
going to happen in a situation like this is they're going to give me a point.
yeah.
If they do, we call this an indefinite integral. And so normally what happens is, keep in mind, like I said, we do two different situations. Sometimes we integrate derivatives to push them backwards to where they were, and then
Mm-hmm.
sometimes we integrate actual functions. So if I was doing this and then I wanted to know what c was, they would have to tell me what the point is. So say me they told me the point was 4, 2 was on this graph. I would replace this y with a 4 and all those x's with a 2, and then I would find out what c is. Does that make sense?
Yeah.
All right, so let's take a look at this. All right, these are a little tougher. What are you going to do first?
You're gonna bring the x up.
So it's going to say 2x to the what?
Negative power 3
Good. Now what is it? What am I going to write now?
plus 8x to the negative power 2.
Good. All right, and then we're just going to keep the 6x, right?
Uh-huh.
All right, so now if I'm going to integrate this, what am I going to do first? I'm going to write the letter,
Mm-hmm.
and what am I going to do the power?
You add by 1.
Add by 1, so what's it become?
Negative 2.
Now, I'm either going to divide by negative 2 or multiply by its reciprocal. And again, dividing by negative 2 sounds fine. What's 2 divided by negative 2?
Negative 1.
All right, so I get negative 1. Now what am I going to do?
You go on to the next term and you add 1 to the.
So what I'm going to do is, if I'm doing this on my paper, I'm going to start by writing x.
Yeah.
And so you notice how I leave a gap between them?
Mm-hmm.
And that's why I said it's almost like I'm kind of doing it backwards. I'm going to do this and then work it forwards. So I write the x, and then what do I do to the exponent?
You add by 1.
So now what's it become?
Negative 1.
And now I'm going to divide by negative 1, so it's going to become?
Negative 8.
And then I move on.
Mm-hmm.
And again, I look at this, I write the variable, and see, this is how when you're doing integrating, it's helpful, I think, to keep you from taking this 6x and calling it a 6.
Yeah.
Because by starting, notice how each time I start by writing the variable, okay?
Mm-hmm.
So now there's a variable there, and then I ask myself, what's the exponent? It's a 1, so I have to add 1 to it. So what's it going to become?
It's going to become x to the power 2.
And now I'm going to take the 6 and divide by 2. So what am I going to get?
Plus 3x squared.
And then put a plus c on the end. Right?
Yeah.
All right, try doing D.
All right. All right, so I got negative 3 halves x to the power of negative 6 plus 3x to the power of negative 1 minus 4x plus c.
Awesome. That's perfect. Now, if I wanted to get rid of the negative exponents, what would I do?
You'll bring the x down, but instead of being a negative exponent, it'll become a positive.
Right, but think about this fraction. What am I going to write? Negative 3. And then what am I going to write? Because think about
over.
this. This is the same thing as negative 3x to the negative 6 over 2. This is, right?
Yeah.
So if you kind of visualize it becoming this, then what's going to happen?
Wouldn't it become 2x to the power 6?
Exactly.
Yeah.
And then what will we do with this one?
That will become 3 over x.
All right, you cool with that?
Yeah.
All right, so try this. What's different about this?
It's honestly, it's grouped. Yeah, it's grouped.
Well, yes and no. What's not? In all these other examples that we've done so far, even if the powers were down here in the denominator, we ended up with a bunch of terms with powers, didn't we?
Yeah.
Okay? Now, you're right. There's another way to integrate where we have groups, but what would happen if I multiplied this? What would I get?
You'll get x squared plus 5x.
And see, in this case, I'm changing it so I can see what the powers are. Does that make sense?
Yeah.
So we're not going to use the reverse chain rule just yet. So what would I get when I do the derivative of this?
You get. I'm just doing mine. You get 1/3. Yeah, you get. Yeah, no, wait. You get the power of 3, and then you get 1/3. Yeah, 1/3 to the. And then with that, you write down the x, you add 1 to the power, and then you get plus 5/2 x to the power 2.
Right. Okay, and then we'll put a plus c. And I can't stress this enough. I don't think I did in class enough. Anytime that you do integration and there's no boundaries, always put a plus c at the end.
Yeah.
Well, we did it in class. We pretty much only kind of talked about only putting a plus c if you knew you were trying to find the original equation.
Yeah.
All right, so try this one.
Alright. So I got 6 over 4 x to the power 4 plus 2/3 x to the power 3.
Oh, yeah, once again. Say it again. What did you get?
I got 6 over 4 x to the power 4 plus 2/3 x to the power 3 and plus c.
And then plus c. And we'd probably reduce this. What would this actually become?
That'll become 3/2.
Yeah, exactly. I mean, if you were using it for something, it wouldn't make it wrong or anything.
Yeah, I try to be careful with those because, like, when I try to do mental math, it kind of causes trouble. So I'm kind of careful with that.
Well, that's smart. Better safe than sorry, right?
Yeah.
All right, I got you. All right, so then take a look at this. What are we going to do in a situation like this?
Right there, we can use the FOIL method, then distribute the x.
Exactly. So what happens when I multiply these two guys together?
I use a box method. I don't use the FOIL.
Well, you can use
Yeah.
whatever method you want. What do you get when you get it?
Okay, I got x squared plus 10x plus 16. Oh, wait.
So
Wait,
you got
I
a
don't know.
negative 8x.
Oh, wait.
Positive
Oh,
2x?
I forgot the -8.
The box method failed you.
Yeah.
What
It's just I
happened?
just rushing. I rushed. My bad. My bad.
So consider this. If you multiply, think of it like distribution. I'm going to
Mhm.
multiply everything over here by x and then everything over here by 2. What's x times x?
X squared.
Now, what's x times -8?
-8x.
Now, hold that in your head. What's 2 times x?
2x.
So, what's 2 minus 8x? 2x minus
Negative
8x.
-6x.
And then the last one is 2 times -8.
Yeah, -16.
Okay? Now,
Yeah.
what do we got to do now, though?
You distribute the x.
So now this will become what?
X to the power 3 minus 6x squared minus 16x.
Exactly. And see,
Yeah.
now that we've got a bunch of powers, we're going to integrate it. We want terms and powers.
Yeah.
So what are we going to do here?
You write down x first. You add 1. Then get 1/4 x to the power 4. And then, yeah, add 1 to the power, divide, you get -2.
Good.
And then you write down the x, add 1, and then you get 8 plus 8. Yeah, no, minus ax squared, and then plus c.
Okay. Now, here's the thing, and then I know that the exam is a little ways away, and I'm not sure how complicated we're going to be able to get today.
Mm-hmm.
When we do this, when we do the integration session towards the end, we'll focus on some more of the difficult problems. But here's what I think people underestimate. You've got to be able to integrate something like this, like no problem. Do you know what I mean?
Yeah,
And
yeah.
the thing is it's one thing to say that, and then the other thing is to do the derivative. How would I do the derivative of this? What's the
You do
derivative of
the
that?
you do the opposite. So like in
So,
this case, you subtract by the power and then multiply.
so what would I do?
So what
If
you'll
I wanted to
do,
find the derivative of this, what would I do?
derivative of
Of the one I made an X or the box around. If I wanted to
so.
find the derivative of that, what would I do?
Oh no. You'll multiply by the power, then subtract by 1. Yeah.
Exactly. Do you see what I'm talking about? Now think about
Yeah.
what you just said. Multiply by the power and then subtract by 1. When we integrate, we add 1 and then we divide by the power.
Yeah.
So the thing is, when you're integrating, you need to think that. When you're doing the derivative, you need to think, be able to, and again, they're very similar and backwards, and that's why people
Mhm.
mess them up all the time. But if I wanted to find this derivative, it's going to be 3x squared minus 12x minus 16. And see, you need to be so smooth with that.
Yeah.
And the same thing with this. And what I need to get across to you is that when people mess up in these integration problems, a whole lot of times it's just because of little slip ups with the integration or the derivatives. You know what I'm talking about?
Yeah. I got you, man.
And so, because they're so similar and yet backwards, you really got to be able to do both of them cold. Now, tell me
Yeah.
about this. How would I fix this?
You'll bring the x up, only the x.
All right, so what happens is it's going to be x to the third times all this stuff.
Yeah.
And then the 2 is still going to be down there. All right, so now what are we going to do?
Wait. The power 3 is going to be negative, right?
Oh, good call. Thank you. So now what are we going to do?
You'll distribute the x to the
So
negative
what's
power.
x to the negative third times x to the fourth?
Just x.
Okay, and then what's x times the negative third times negative 2x?
Minus 2x to the power -2.
And then what's this times this?
Plus 5x to the negative third power.
Plus 5x to the negative third power. All right, now this is all being divided by 2. What am I going to do with that? Because what I want is I want individual terms.
Mm-hmm. Whoa.
So think about the first one.
Oh, you can. It's the same thing as. You can just like make it separate. So x over 2
Which is the
minus
same thing as dividing by 2 is the same thing as multiplying by what?
the reciprocal. Yeah.
So this would be 1/2 x, right?
Yeah.
And then what if I divided this by 2? What would it become?
That will become negative 1 to the x. Yeah. Yeah. That.
Right?
Yeah.
And then what would this become if I divided it by 2?
5 halves.
And see, now I've got myself some nice terms. Now, fractions and negative exponents is not awesome, but now I can go ahead and I can do the integration. So what am I going to write? First x, then what?
You add 1.
And so it's going to become a 2. And either I multiply or divide by 2 or multiply by the reciprocal. What happens when I multiply by the reciprocal?
You get 1/4.
Now I come over here and I write the x. I add 1, so it becomes what?
Negative 1.
And now I'm going to divide by negative 1 because I feel like that's a good one. What's negative 1 divided by negative 1?
Positive 1.
So I'm just going to put plus, right?
Yeah.
And then here I'm going to scooch over. I'm going to write the x. I'm going to make this a negative 2. And now again, when I look at this, even though we're dividing, I'd rather multiply by the reciprocal because that's going to be multiplying by negative 1/2, right?
Yeah.
So that's going to give me negative 5 what?
Over 4.
Exactly. And then put a plus c on the end.
Yeah.
And if I wanted to fix it, I would just make this 1 over x and this 5, well, 5 for, x to the negative, to the second, right? Positive second.
Yeah.
All right? How's that feel?
Feels good. It just feel a bit rusty, you know.
All
No,
right.
well, not rusty. I just like.
I know.
those
Well,
parts.
that's the thing, though. Like, it's all in your brain.
Yeah.
By doing this now, like I said, it's going to pull it back up to the front for a little bit.
Yeah.
And then, like I said, when we go at the end and try to revisit this, it won't be like you haven't thought about it for forever. Do you know what I mean?
Yeah, I get what you mean.
All right, so try this one. Multiply those together. Tell me what you get.
No, I'm gonna try the FOIL method. All right. So what you did, you multiply. Yeah. Okay. So you got x squared, and then you'll get plus 5x, right?
Right. And see, this one's not too bad, but do you see how it's going to be 4x plus 1x?
Yeah.
And then what's 1 times 4?
4.
All right. So now all I can do is integrate it.
Yep.
What do you get?
I'll get 1/3. I got 1/3 x to the power 3 plus 5 halves x to the power 2 and plus 4x and then plus c.
All right. Now, we could do the reverse chain rule with this, but we haven't talked about it yet. So it'd probably be easier to just, to the second power, we can square a binomial, right?
Yeah.
So what do I do to square a binomial? Square this, multiply them together, and then double it. What's negative 3 times x?
Negative 3x.
Now double it.
Negative 6x.
Now square this.
That will become plus 9.
All right. So now let's integrate that.
So that'll give you 1/3. Yeah. Yeah. And then minus 3x. Yeah, 3x too. And plus 9. Plus 9x.
Right. Plus c.
C. Yeah.
Okay, that's awesome.
Yep.
All right. Now what about this one?
Okay, so that's the same thing as x 1/2. So you'll give that an exponent because like you need exponents to find
All right.
you
So
integrate.
that's going to be 2x to the 1/2 power minus 1 all squared. Yes?
Yep.
All right. So let's square this. Just like we did a second ago. Square the first term. What's 2 times 2?
4.
And then what's x to the 1/2 times x to the 1/2?
1/4. Wait,
So
x to the 1/2 to the that would.
what do I do to the exponents when I multiply them?
Oh, you add them. So
So, and think about it. This is the square root of x times the square root of x. If I multiply them together, I'm going to get x, right?
yeah.
Yeah, that makes sense?
Wait, no. You did that. Wait, aren't you? You're supposed to do 1/2 plus 2, right? Because that's the rule, right?
Say that again now?
Because like, aren't you supposed to add 1/2 with 2? Or I'm messing that with something else.
Well, I'm not sure. Because we're just still talking about this one term yet, right?
No, because like, don't you have to when you? It's an exponent rule when you multiply exponents.
What do you do to when you multiply bases that have exponents, what do you
Yeah,
do to the exponents?
you add them. Right?
So what's 1/2 plus 1/2?
Um, oh, it's 1. It's 1.
That is, right? It feels like it should be something else. Doesn't it feel
Yeah.
like it should be 1/4 or something?
Yeah.
But 1/2 and 1/2 is going to be 1, right?
Yeah.
All right, so that gives us 4x. Now, let's multiply. What's -1 times 2x to the 1/2?
Negative 2x to the 1/2.
Now double it,
Negative 4x to the 1/2.
right?
Yeah.
Because I'm only multiplying a base times a number, so that the power is not going to change, right?
Yeah.
And now square the last one. What's -1 times -1?
Positive 1.
All right, so now I've made this much more workable.
Mm-hmm.
How are we going to integrate it?
You add 1. Well, yeah. First you write down the x. You add 1, and then you do 4 divided by 2, which gives you 2. And then you do the same thing. You write down the x. Add 1 to 1/2. You get 3/2, and then you'll get -8. Yeah, -8 over 3. When you do that, when you multiply the reciprocal.
Right? Because I'm going to do 2 over 3, 8 over 3, right?
Mm-hmm.
And then what?
You put an x on the 1, and then plus e.
Okay?
Yeah.
All right, what about this one?
That would be the same thing as x to the power 1/3.
Excellent. And now multiplying times this, and it's just distribution.
Mm-hmm.
So this is going to be x to what power?
7/3, right?
7/3. All right, now what's x to the 1/3 times 1?
X to the 1/3.
All right.
Mm-hmm.
All right, now we got our powers and we got our terms separated. What are we going to do now?
You write down the x, and you add 1 to 7/3.
So in this case, think of 1 as being 3 over 3.
Oh yeah, that is a good, yeah.
So when I add 3 over 3 to that, what is it going to be?
You get 10/3.
And luckily there's nothing in front of here, and so now I choose to multiply by its reciprocal, right?
Mm-hmm.
And so then do the same thing here. Think of 1 as being 3 over 3.
You get 4/3.
And again, multiplying by the reciprocal.
And then plus c.
Okay?
Yeah, that's a good tip. I didn't look at it that way.
Whenever you're dealing with fractions and you have to add a number to it, remember that the denominator can help you as far as, well, say, what if I was adding 2 to it?
It'll be two.
What's equal to 2 that divides by 3? It would be 6/3 is equal to 2, right?
Yeah.
Yeah, so again, don't discount mental math. Mental math can kind of help you, but
I mean, the thing is, I can also mess you up.
well, that's right. But here's what I would say is you should practice the mental math and then back it up with the calculator. And then the more you do that, then what will happen is you'll become the mental math is more reliable. The
Yeah.
problem is if you don't ever do mental math, well, then quite honestly, you don't ever get good at it.
Yeah, that's true. That's true. Good point.
All right, try this one here, and then we'll switch gears, I think. What am I going to do with this one?
You'll only bring up the x.
So it's going to be x squared times, x to the negative 2, right?
Yeah.
Times x squared minus 1, right?
Mm-hmm.
And that's going to all be divided by 2. So I'm not going to worry about the 2 just now, but I can't forget about it. I'm going to put this to remind me. So what's this going to be?
That's gonna become x. And then minus.
X to the what? Power.
Oh, wait. Yeah, that'll become x. Yeah, that'll just become x, right?
X to what power?
0.
What's anything to the 0 power equal to?
1. Oh.
So anything to the 0 power is equal to... Now, keep in mind, x is actually to the first power. We just don't write it.
Mm-hmm.
Okay? So x to the 0, it cannot be the same thing. Does that make sense?
Yeah.
So this times this is actually going to be 1, right?
Mm-hmm.
And then what's times this going to be?
That'll be plus x to the negative power 2.
Well, it'll be negative 1, so it'll be...
Oh, yeah, negative, yeah.
Right? All right. Now, we're going to divide by 2, right?
Mm-hmm.
So, what's that going to be?
That would be 1/2 minus...
Here, I'll just write it like this. 1/2, and then...
1/2 x, well, negative, yeah.
Okay, negative 2, right?
Yeah.
And see, now that I got it situated, now I can go ahead and I can do my thing.
Yeah.
So what's this going to become?
That'll become 1/2 x.
And then I'm going to go over here. I'm going to write this x. I'm going to do what to this?
You add 1.
So it's going to become negative 1. And again, whenever I'm dealing with these negative exponents, I'm going to slow down a little bit. So now I'm either going to divide this by negative 1 or multiply by negative 1. Because what's the reciprocal of negative 1?
1, right?
But is it negative or positive? What's the reciprocal of negative 1?
It's positive 1, right?
What's the reciprocal? Tell me what I do.
You...
Flip it upside down, right?
Yeah. Yeah.
What are they? What's 1 divided by negative 1?
Negative 1.
Exactly. So the reciprocal of negative 1 is the same thing as its... So I'm going to think of this as multiplying by negative 1. What's this times negative 1?
That'll give you plus 1/2.
Yeah, exactly.
Okay, I have a question. So the reciprocal, is that the denominator? Because I never understood that.
It's both.
It's both?
So for example, if I say, what's the reciprocal of 2/3?
There will be 3/2. Okay.
Okay. What's the reciprocal of 1/2?
2/1.
Okay. It literally means that I'm going to take the fraction and I'm going to put the denominator in the numerator and the numerator in the denominator. Both of them switch places.
Okay.
That's why some people don't say reciprocal and they say flip. Okay? So,
Yeah,
for
because I
example,
thought,
when we're trying to find a slope, if I know the slope is negative 1/3, the perpendicular slope is the opposite reciprocal. So
yeah,
if it's going to be opposite, it's not going to be negative. It's going to be what?
positive.
Positive. And it's
Yeah,
going to be a reciprocal. So it's not going to be 1/3. It's going to be,
3/1.
which is the same thing as 3.
Yeah.
So
Okay.
reciprocal literally just means take a fraction and then flip it upside down.
Yeah, because I remember in middle school, I thought it was the denominator or something.
Well, I mean, and that's because, like, a lot of times what happens is they say stuff like this: what's the reciprocal of this? And it seems like all that's happening is I'm only moving this up.
Yeah. Okay. Yeah. There it is. Yeah. Yeah.
All right, so try this one. What's going to go up to the top?
X to the power 3 with -3. Yeah, it'll become -3. Power -3.
And it's going to be -3. And then what's going to happen is that leaves me this 2 down here. So what I'm going to do is I'm going to just remember that I still got to multiply by 1/2. You with me?
Yeah.
All right. So then when I go ahead and do this, what am I going to get?
You get 1 plus 6x to the power of -3.
And then what I'm going to do is multiply each one of those terms by 1/2.
Yep.
And so that's going to become 1/2 plus 3x -3. Yeah?
Yeah.
So now what am I going to do?
You integrate, and you do that, you get 1/2 x plus x. You get -3/2 to the. Wait, no. You get, yeah. 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 You get -3/2 to the x to the power -2.
Yep.
Yep.
All right, awesome. Okay, so those are some pretty complicated ones. Now let me switch gears here. All right. Let me find this here. Come on, where'd my mouse go? Come on, what am?
Wait, so for these review sessions, are we ever going to do exam-like problems?
Yeah,
Okay.
especially as we get closer.
Okay.
Like what's going to happen now is I'm focusing on some of the basics,
Mm-hmm.
and then what's going to happen is that after we get through some of this basic stuff, then we're going to look at some exam problems. We're definitely going to be doing that.
Yeah.
Oh, God, I did the same thing. So here, I want to take a look at the chain rule. So we already did this. But what happens is that sometimes what's going to happen is we're going to, come on, where are we at here? Oh. All right, well, let's do this. Let's find the original equation. We talked about this, but we didn't do it. Here's
Yeah.
a derivative. This is the very typical exam question
Mm-hmm.
where they give you a derivative and then they ask you to find the original equation.
Mm-hmm.
Try doing it.
All right. All right, I finished.
All right, so tell me what you did. We're
So,
moving this up here, right?
mm-hmm.
And when you multiply them, what'd you get?
Oh wait, that's supposed to be -2.
Good, thank you.
Yeah, okay, yeah.
Now what?
I got I got 2x minus 6x to the power of -2 plus c.
Well, keep
Oh
in
wait, not yet,
mind,
not yet, not yet.
not
My bad.
yet, right?
Yeah, yeah.
Now what?
After doing that, I added 1 to the power, so I just integrated. So when I integrated, I got x squared plus 6x to the power of -1 plus c.
All right. Now, for example, if you have an exam question like this, one point is going to be probably, me seeing this. Okay?
Mm-hmm.
Like, it's awesome that you do all this stuff, but where the point comes in is if I can see this. Okay?
Yeah.
So now what?
So after doing that, I just plug in the numbers. So yeah, like that.
And when did you find out?
And from then on, I got x squared plus 6 over x minus 4.
So you find out C was -4?
Yeah.
Oh, wait, the wrong one. So this is going to be -4, right?
Yeah.
All right. So that right there is a very common question to get asked.
Yeah.
Now, when we've got a group and we're going to undo the chain rule, the thing is, especially for, I can't say this for doing derivatives, but when it's an integration, it's always going to be some number times x plus b. Or, don't get me wrong, it could be backwards. It could be like 5 minus 3x. But it's always going to be just a number times x. It won't be any power or anything, okay?
Mm-hmm.
So anyway, whenever you see this to some power, then this is the way we integrate it. What's going to happen is that we're going to add 1 to the power. We're going to multiply the reciprocal by the front or divide by it. But because it's a group, I almost always just multiply by the reciprocal, okay? And then what I'm going to do, well, here, do you remember how to do derivatives when we do the chain rule?
Use, well,
So if
first
I
thing,
showed you this, 5 minus 3x to the fourth, and I asked you to find the derivative, what would you do?
so first you subtract by the power.
What do you do first when you're
Oh no,
doing
you
the derivative?
multiply, you multiply, you
So
bring
it
the
would be
4 down.
4 times 5 minus 3x, and then what do?
You subtract by the power by 1.
And so it becomes the third. Now what else do
Yeah.
you do?
You get the derivative of negative 3x.
So the derivative of the inside, which in this
Yeah.
case is going to be negative 3, right?
Yeah.
And then I multiply by negative 3. Okay?
Yeah.
So what happens is that if I'm going to do integration, again, it's going to be backwards, but it's just going to be the opposite, the same stuff. So just like before, I am going to start by writing this 5 minus 3x, but I'm going to add to the power, so it's going to become the fifth. And then I'm going to, like I said, instead of dividing, when it's a group, I always just multiply by the reciprocal. All right?
Yeah.
So now I've added and I've divided, technically.
Mm-hmm.
And now what I'm going to do is I'm going to multiply by the reciprocal of this also.
Yeah.
So that's going to be times negative 1/3.
Yep.
And so then it becomes negative 1/15 to the fifth plus c.
Yeah.
Right?
Mm-hmm.
All right, so take a look. Here's an example that kind of goes through that same thing. Raise the power, multiply by the reciprocal, and then multiply by the reciprocal of the number in front of x. Okay?
Mm-hmm.
Same thing. So, try finding the original equation with this one.
All right.
What did you get?
I got the same thing.
All right. All right. remember here, now we have limits. The biggest limit is always on top, and the smallest limit's always on the bottom.
Yeah.
Sometimes what happens is that they just ask you to find they ask you to integrate it, and then they give you some limits. And then do you remember how it works?
Yeah, you have to like each limit goes to you plug in the each limit and you should after you do that okay
Exactly.
yeah.
So what we're going to do is we're going to integrate it. That's this. Then we're going to substitute in the b, and then we're going to substitute in the a, and then we're going to subtract those two, right?
Yeah.
All right. So try this.
Yeah. 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 Well, I
Now
didn't
just
get that, but
well, let's take a look and see what's different. Because don't get me wrong, I was doing it pretty fast, and I didn't get a calculator until the very end. So this part, does this match you?
yeah.
And then so then this,
Mhm.
And so then when I did the derivative, I got x to the third. So then I divided by 3 and I got 2. And x to the negative 1 divided by negative 1 is positive 1, right?
Mm-hmm.
And then do you have this?
Well, the thing is, I got an answer, but I messed up like on the second step. Oh no, not the second step. When I was
When you were substituting?
No, when I was integrating, it's because like I went too quick, and then I just like miswrote a number.
Oh, right.
Yeah. So yeah, I gotta take these slow.
Take it easy. All right. But there's the gist of this, right?
Yeah, I understood. I understand how to do it.
Now, keep in mind, this could also have been a problem where they gave us this function and then they said, find the area under the curve from 2 to 1. It's going to be exactly the same process, right?
Mm-hmm.
Sometimes I'll do it to a function, sometimes I'm finding an area of a curve, but it looks the same thing. Try doing this one. Try doing it slower.
All right. Oh, Mr. Cross, I got my final answer.
Someone will tell me what we did first. How'd you do it?
So
You made this what?
I made it to the power of 1/2.
All right, now what'd you do?
I wrote down 5x plus 1 first, and I added 1/2 by 1.
So what's that going to be?
3/2.
Then what'd you do?
I had multiplied by the reciprocal.
Then what'd you do?
I took the reciprocal of 5x, which gave me 1/5, and I multiplied by 2/3.
Is that what you got?
Yep.
Then what'd you do?
I used the limits and plugged them in my calculator.
And what'd you get?
I got 128 over 15 minus 2 over 15.
2 over 15?
Yeah. which gave me 126 over 15.
So let's see here. 0. The second part definitely makes sense. All right, that looks awesome. I didn't work it out, but that looks like that looks good. All right. Try doing this one.
Mhm. All right, I finished.
What'd you get?
That's my final answer.
Yeah, what'd you get?
2.
That's what I got too. That's awesome. All right, now keep in mind the other thing that an integral is used for is to find area under a curve. All right, now what happens is that in these earlier problems, like this could be anything. This could just be a function, whatever. If there's boundaries, well then you can, then you can evaluate it, and that way that's why you don't have to have a seat. The answer to this question is what is that? When I do from 2 to 3 or 3 to 2. If there's no boundaries, then I have to put a plus C. If I'm trying to find the area under a curve, I'm going to do the exact same thing. And for example, here, if I take this very simple function, y equals 2x, it's going to make this line over here. And so if I integrated it from 2 to 0, well, so integrating 2x is pretty easy because it's going to be 3. Wait a minute, what do we got here? Oh, 2x, it's going to be x to the second divided by 2, so it's going to be x squared. And then when I put this in there, I'm going to get 4 minus 0. And if you take a look at the triangle, if I use what I know about finding the area of a triangle, 1/2 times the base times the height, 1/2, the base is 2, and the height is 4. Well, 1/2 of 8 is 4. This is going to be able to find the area under a curve based on 2 boundaries and the x-axis. And again, the beauty of this is that it literally isn't anything different than what you were just doing. What I want you to do is try doing this one. Find the area under the curve from 1 to 9 with this function here.
Right.
Oops. Did you do what I did?
I got 8/3. Oh wait. Hold on. Oh shoot. Wait, I think I messed up. What? Okay, well I did Wait, how'd you get 8?
So you got this, right?
Yeah.
So I'm going to raise it by 1 and get this, right?
Yeah.
Now I'm going to multiply by the reciprocal. What's the reciprocal of 1/2?
2.
What's 2 times 4?
8.
That's where I got the 8.
I messed up because I made these small details really mess you up. I made the
Is it a
one.
reciprocal again?
No. I made the 1/2. The 1/2 was positive, not negative.
Well, the thing is, I don't know if you were watching, but I did the exact same thing. But then I
Yeah.
started to do it, and then I realized that I had moved it up, and then I hadn't written it that way.
Yeah.
And that'll mess you up. And see, I know, well, because clearly this is not a very difficult one. There's going
Yeah.
to be others that are longer or whatever. But see, that's the thing. I mean, take some time and work some smaller ones and and focus on not making those little errors because then what'll happen is, to go through a big long problem that's got a lot going on and then to find out that near the beginning you made like a little mine assignment error or something like that, well,
Yeah.
that's like painful. It makes you cry.
Yeah.
It does me. All right. Well, that's all I got for you for right now. You got any questions for me before you go?
Are we gonna go over area and volume?
Yeah.
Okay, yeah, I need to go over that.
All right. Well, what I want you to do is try practicing some of these problems with just the regular, just finding integration and finding some area ones, and then we'll practice like between the curves and finding the volume. We'll do that.
So the next, what's gonna be the next unit on?
Honestly, I don't remember. I'll take a look at the thing and maybe I'll switch it around.
Alright. Yeah, because I want to go over trig. That's painful, you know.
Yeah, I heard that.
Yeah.
Well, do me a favor, like maybe tomorrow, I don't know, tomorrow's a short day, but when you got class, maybe we can talk and then we can take a look and see what's scheduled. And because, like I said, I can change it around, I can move it to anything.
All right. Yeah.
All right.
So are we gonna? Well, what's the plan for tomorrow?
Well, quite honestly,